Hello everyone. In this video, I'll be explaining on the preparation methods of aldehydes and ketones, where aldehydes and ketones can be prepared in a single chemical reaction. Now the first one is ozonolysis of alkenes and ozonolysis of alkenes and alkynes. Now let's first do the reductive There are two ozonolysis methods for the preparation of aldehydes and ketones. The first one is reductive ozonolysis, and the second one will be our oxidative ozonolysis. Now let's check what is reductive ozonolysis. Let's check first for alkenes. What happens when alkenes undergo reductive ozonolysis reaction? Now this take an alkene molecule, ozonolysis means O3 ozonolysis in the presence of zinc, water, CH3CHO. As aldehydes are formed, this is known as 3 carbon atom 1 2 3 3 carbon atom. This is known as propene, from propene, and this is our acetaldehyde plus HCHO. Formaldehyde is formed. Now how is this formed? Now when our propene, the alkenes react with ozone, let me take the mechanism here. Ozone, this is our CH3C. When it reacts here, ozone is this O3 molecule. The three oxygen atoms come and attach here, 1, 2, and then these are CH2, and then the third ozone molecule adds up in this way, and ozonamide. This is an ozonamide molecule. Now when it reacts with zinc and water, now the zinc takes away this oxygen as zinc oxide ZnO, and then there is breakage of this bond in this way. Therefore this becomes CH3C double bond O, that means CH3CHO. From CHO it forms CHO, and then another one is CH2 double bond O. We will be getting CH2 HCHO, and it will be getting the acetaldehyde and formaldehyde in this way. Now let's check another type of reductive ozonolysis of it. CH2 double bond CH2. This is an ethene molecule. When it undergoes ozonolysis in zinc plus H2O, we'll be getting here 2 moles of formaldehyde. Now let me show a short trick method on how to remember how ozonolysis reaction. This is the actual mechanism that takes place. Now a short trick method is here. This is our ozone molecule. Now just write in this way the ozone molecule. Now there is the both the bond breaks along, and then it goes like this. Therefore one CH2 takes this oxygen, another CH2 takes this oxygen. Therefore there will be formation of, since both the bonds break up, in this case there will be formation of 2 molecules of formaldehyde. Now in another case, C double bond CH2 CH3 CH3. This also are another ethene molecule. When it reductive ozonolyzes in zinc H2O, the short trick method, just apply the same method here. This would break up. This part would take this oxygen with the double bond in this would take. Therefore we will be getting, for this part, CH3 CH3. Just attach the double bond oxygen here, plus for this case it will be HCHO. Therefore formaldehyde, and this is known as our acetone or ketone, is formed in this process. Now another example here. For another example here is Now we need O3 and Zn zinc plus H2O. The same method can be applied here. We know that there's an H here, oxygen, double oxygen. Just break the bond in this way. Therefore, we'll be getting CHO in this process. So all the reactions, reductive ozonolysis, the actual mechanism occurs in this process. Even if you do all these reactions in the same mechanism as this, the product would be same, and therefore this breakage of this bond is a short trick method that I used to study. How I used to study and remember the reductive ozonolysis of alkenes. Now let's check out the reductive ozonolysis of alkynes. Even in alkynes, the same type of reaction takes place. HC triple bond CH when it breaks with O3, and then Zn plus H2O. Here glyoxal is formed. CH. In this case, only one bond is left out, and then only two bond breaks up in this case. Therefore, the reaction here would be, when it reacts with ozone, we'd be getting here HC, and then the ozone will come out, and in the bond here, our H is here, one bond would be here, one oxygen with one bond. Now there is breakage. Now when it reacts with zinc plus H2O, the zinc comes and takes this oxygen as ZNO, the same gas that happened in the reaction, reductive oxidation of ozonolysis of alkenes. Now now this bond breaks up, but this bond does not breaks up, and then there is breakage of this bond in this way. Now even this bond will break up, but this bond does not break up, and then there is breakage of this bond, and the groups go out separately. But since there is one bond is still left for carbon, hydrogen, this become our double bond oxygen. Therefore this is known as glyoxal. Now let's check one more example. Another example, if we take here in this case, now CH3 C triple bond C CH3. Now when it goes O3 Zn plus H2O, we'd be getting CH3 C, one bond would remain as it is, and then add double bond O, and here a diketo group is formed in this process. The same reaction can occur here. Excuse me. CH3 C, one bond would be still here, CH3, one oxygen would come in it, the second oxygen. Now when it breaks with zinc plus H2O, the zinc comes and takes away this oxygen. This bond breaks, this bond would remain as it is. This bond breaks, and this breaks. Therefore there will be additional this CH3 C carbon CH3 double bond oxygen. Therefore in this way a diketo group is formed. Now these are the reductive ozonolysis reaction of alkenes and alkynes. Now let's check the oxidative ozonolysis reaction of alkenes and alkynes. Now in the carbon CH3H, this is an alkene molecule. Now in the reductive ozonolysis, oxygen and H2O2 peroxide is used in this case. Now in oxidative ozonolysis, zinc plus H2O was used, but in this case we will be using hydrogen peroxide. Therefore we would be getting here CH3 C double bond oxygen CH3 plus CH3 C double bond O, and then OH group. An OH group would be formed in this case. Now this H2O2 can be written as HO and then OH. Therefore, this breaks up in this molecule breaks up in this way to form the compound. Therefore, the one this also breaks up. One group goes in the digestive here, another group comes in the digestive along with oxygen atom. Therefore, the process is formed in this case. Now we know. Let's check the difference between oxidative ozonolysis and reductive ozonolysis. Take a molecule here, CH3, C, triple bond CH. Now, if it undergoes O3, Zn plus H2O, this is our reductive ozonolysis. And what happens when O3 plus H2O, then this is oxidative ozonolysis. What happens to this molecule? Now, in oxidative ozonolysis, only two bond breaks up. Therefore, there will be for CH3, C, one bond would remain C, and then H. Just add double bond or double bond oxygen here. Now, what happens when oxidative ozonolysis takes place? We'll be getting CH3, C, double bond O, one OH group, and then another group be here. In this case, would be H, C, double bond OH. Now here in this, for this type of molecules, there HO, OH. Now it breaks up in this way. Therefore, there is formation of alcohols in the oxidative ozonolysis of alkenes and alkynes. Now in the exams, the questions may be asked like A, number O3, and then Zn plus H2O. 2 moles of CH3, C double bond O, CH3. Now, what is A? Now, we know that when ozone and Zn plus H2O is here as the reaction medium, we know that this is a reductive ozonolysis reaction. Therefore, from here, just since there are 2 moles, a short trick method is here, 2 moles of this is a ketone. Therefore, just attach here. These are C double bond O, CH3. We can get the answer directly from the product. Right, again, since there are 2 moles, write the 2 moles of oxygen. Just remove this oxygen in this case and attach this carbon and carbon. Therefore, our A, the product A will be C double bond C, CH3, 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 and then CH3. Therefore, this is the starting material for this reaction. Now, another therefore, different examples may be given here. Therefore, you should understand that. Let's take another example here. A is given. Then what will be our product here? A is given. First one is O3, and then Zn plus H2O. Benzene ring, and then carbon H double bond O plus double bond OH. Now just attach these two products in the reaction medium. Attach here, you can write it like this: carbon C H double bond O, and then H, and then this. Just remove this 2 oxygen atom and then attach the carbon to attach the carbon and carbon atom. Therefore, you'll be getting the starting material as A. Therefore, in this way, the oxidative ozonolysis as well as the reductive ozonolysis of alkenes and alkynes takes place where ketones and aldehydes are both prepared.